Okay, first problem on the study guide. We're trying to do a box and whisker plot. We've got these scores. We want to first arrange the scores from smallest to largest. So we've got 6, 6, and 7. Looks like 10, 10, 12 is next. Make sure, like, if a number like 10 happens more than once, 6 happens more than once, they all get written down. Let's see, we've got 21, 27, 38, 43, 51, and 52. So we make sure to write down all the numbers. It says there's 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Verify 3, 6, 9, 12. To do the box and whisker, we want to split these into quartiles. So since there's 12 scores, divided by 4 makes 3. So every 3 scores, we're going to put a slash. So 1, 2, 3, slash, slash, and slash. Quartile 1 is simply going to be the average of 7 and 10, which is 8.5. Quartile 2 is the average of 12 and 21. That's 33 over 2. Which is 16.5. Quartile 3 is simply going to be the average of 38 and 43. That'll be 81 over 2, which is 40.5. Then we have our minimum score of 6 and our maximum score of 52. So to create the box and whisker, we're going to use these 5 numbers. And usually you do this with a sort of a scale, but I'm just going to kind of ballpark it, and that'll be fine for the sake of the test. So put a dot here for 6. 8.5 is kind of close to 6, so I'll put that kind of close. And then that's 2.5, 16.5 is 8, so kind of maybe about here for 16.5. I want to actually raise 8.5 up a little bit because we're going to make a box out of that. Next number is 40.5, which is 24 more. So this was 8, so 24 might be about here. And then 52 is another 11.5 more than that, so maybe about here. So we got our min, our max, and our 3 quartiles, and we're going to put a box from here all the way to here. Put a line down the middle, one out here, one out there, and there's our box and whisker. That'll be sufficient for me. Again, it's kind of ballpark that, obviously really short, bigger, a lot bigger, not quite as big. Just kind of arrange it like that. As long as you have the correct numbers for the min, max, and quartiles, I'm not going to count off a lot for your artistic ability on that, but just make sure you give me the correct numbers for each of those. Number 2, the number of birds tripled every hour. There were 20 birds at first. How many were there in 5 hours? So we're going to use this formula. A sub t is the final amount of birds. A sub 0 is the initial amount of birds. Y is how we're changing. In this case, it says tripled every hour, so y is going to equal 3. So it says 20 birds at first. So 20 is a sub 0. We're multiplying that times 3. And it says it triples every hour, so t is 5 hours, that's 3 to the 5th power for the final number of birds after 5 hours. I want to actually evaluate that. I don't have a calculator open right now, I'll just use this one. If I type in, oh, that doesn't have batteries. One of these will. If I type in 3 to the 5th power, it's going to be 243. So 20 times 243. Order of operations says we do the power first, make sure that happens. Times 20 comes out to 4,860. And for the sake of the test, it's going to be kind of like that. I'll tell you the rule for increasing birds. In this case, tripled, quadrupled, 4, doubled, 2. So whatever that is, that's tripled is what y is. Number of birds at first, that's what a sub 0 is, and how many hours, that's what t is going to be. So basically it's just create the structure and then apply the order of operations. Number 3, the weight of a body on or above the surface of the earth varies inversely with the square of the distance from the body to the center of the earth. So weight varies inversely with the square of the distance. So that's going to be weight equals k divided by distance squared. So our first statement that's going to give us weight and distance, a body weighs 10,000 pounds at a distance of 80,000 miles, which means 10,000 pounds over 1 equals K over 80,000 squared. To square 80,000 is square 8, which is 64. And there's 4 zeros double it, we're going to get 8 zeros. If I cross multiply, I get 1 times K is equal to 10,000 times that number. So 64 followed by 8 zeros. Multiply by 10,000, which puts 4 more zeros on it. Gets me K is equal to that number. So now weight equals 64,000,000,000,000,000,000,000 over D squared. So I can call the number by the right name here. Millions, billions, 64 trillion over D squared. How much would it weigh 2,500 miles from the sun to the earth? So now 2,500 miles is the distance. So W is equal to 64 trillion over 2,500 squared. That's 625 over 25 squared, 0, 0. So 0, 0, 0, 0. 6,250,000. Again, a calculator can help me with that. 64 trillion divided by 625, or 6,250,000, comes out to 10,240,000 pounds. All right. So expect to be similar, and expect K to be an extremely large number when we start dealing with the weight of objects, and the typically we're talking about comets, asteroids, things like that. So they weigh a lot. So expect it to be big numbers on that one. Number 4, Paula ran to Hugo in 2 hours while Busking walked the same distance in 8 hours. So Hugo must be a town. Paula and Busking are the people who are doing the moving. Paula's running, he's walking. So let's just draw a picture here. Paula ran. That's the distance Paula ran. He walked the same distance, so he must be going to Hugo also, so distance of Busking, and by the way they're talking, the distance Paula goes should equal the distance that Busking goes. Job 1 done. Once we've established that, Paula and Busking are categories. They tell us times. Paula ran in 2 hours, Busking in 8 hours. Her speed was 9 kilometers per hour faster than his. So if Busking's rate is R, her speed is going to be R plus 9. We're talking about kilometers per hour. So this is kph, this is hours, this is kilometers. So if we just kind of know what our units are. Her speed times her time will be 2R plus 18. His speed times time is going to be 8R. According to our expression over here, they should be equal to each other, so we set those equal. I get 8R is equal to 2R plus 18. Minus 2R gets me that 6R is equal to 18. So R is equal to 3 kilometers per hour. And that is his speed. The question is, how fast did Paula run? And how far was it to Hugo? Those are the 2 questions. So what we found, R is his speed, but we don't care about his speed. It says how fast did she run. So make sure that the rate of Paula is what we're looking for. 3 plus 9 is equal to 12 kilometers per hour. The other question is distance to Busking. The distance is either 8R or 2R plus 18, take your pick. R equals 3, 8 times 3 is 24, 2 times 3 is 6, plus 18 is 24. Either way, it's 24 kilometers. Busking. Number 5, horses sold for $475 each, ponies for only $230. Weir spent $15,325 and bought 10 more horses and ponies. So we have number of things and value, and the values are given in dollars. And we have horses and ponies. So we'll say that Weir bought H horses and P ponies, and every horse cost $475, so 475 times the number of horses. Every pony costs $230, so $230 times the number of ponies represents how much money was spent. So if we take our two facts, fact number one, we were spent $15,325. That's going to be value. This is dollars. The values of the different animals is in dollars. So we take the value of the horses, how much money was spent on the horses, plus how much was spent on the ponies. That should equal the amount of money spent altogether. Obviously, these three numbers all divide by 5. It's not a requirement to do this, but it makes the number smaller. We get 95H. 230 divided by 5 is 46p. And 15,325 divided by 5 is 3,065. So I can use that equation instead of that one, just smaller numbers, a little bit easier to deal with. The other fact, it says that he bought 10 more horses than ponies, so more horses. So if I say H equals P, this is bigger because there's more horses, so I've got to put plus 10 on the pony side. The smaller number plus 10 makes the bigger number. The way this is set up, it looks like substitution is going to be easier. I replace this H with what H equals, so I get 95 times P plus 10 plus 46p is equal to 3,065. So that gets me 95p plus 950 plus 46p is equal to 3,065. Slide the 950 over here and subtract. We get, on this side, 141p. And on this side, 3,065 minus 950 is 2,115. And then I simply divide 2,115 by 141. And we get 15. So P is equal to 15. P is the number of ponies. How many horses did she buy is the question. So if P is 15 and H equals P plus 10, H equals 25 horses. That answers the question they're asking for, so make sure that, again, with all these word problems, answer the question they ask. Don't just stop once you get an answer to an equation. Make sure that answer represents what you're looking for. Number 6, Judy deposited $1,200 she received from Frank at 6% interest compounded annually. What's the total interest earned after 5 years? Our formula for compounding interest is the final amount of money is equal to the initial investment times 1 plus the interest rate as a decimal to the t power. What she deposited was $1,200. That's this. Interest rate is 6%, which is there, but that's 0.06 because we always use decimals. And after 5 years, that's the amount of time. So everything we need for the formula is right there. So the amount of money that she has, what's the total interest earned? So we have to find out how much money she makes first. So $1,200, 1.06 to the 5th power. So we start there. And again, order of operations says this happens first, then times that. So I type in 1.06 to the 5th power, then I do times 1,200, and it comes out to the final amount of money she has in the account is $1,605.87. Once you have the correct amount of money in the account, you subtract what she invested, and that ends up being the interest. So she ended up getting extra $405.87. So make sure, again, answer the question. Again, this formula tells you how much money you have at the end of the investment, including what you started off with. You subtract what you started off with to get the interest earned. Number 7, solving a quadratic equation. 7, 8, and 9 are all solving quadratic equations. We've learned 3 techniques for doing this. This one I'm going to use the quadratic formula. The second one we'll see when I get to it. So, quadratic formula, I like x squared positive, so I'm going to move the 14x to the right. 0 is equal to 15x squared minus 14x plus 3. Okay, quadratic formula, we have a, b, and c. And a is positive 15, b negative 14, c positive 3. The quadratic formula says that x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And the way I recommended doing this formula is to create your proper structure, figure out what these 3 objects equal. These 2 are pretty easy. This means change the sign of b. b is negative 14, change the sign, we get positive 14. 2 times a means to double a. A is 15, double 15 is 30. B squared minus 4ac is a little bit more challenging to evaluate, so if I do 196 is b squared, keep in mind, regardless of b's sign, when you square b, it's going to be positive. Minus 4 times a times c. That's 196 minus, that'll be 60 times 3 is 180. 196 minus 180 is equal to 16. So that's job 1 with the quadratic formula. Just figure out those three values. Minus b changes sign, 2a double a number, b squared minus 4ac evaluate to a specific number. And if this happens, square root of 16 is a nice pretty number that has an exact square root, you should evaluate that square root. Square root of 16 is equal to 4. Once you do the square root of 16 equals 4, the square root symbol's disappeared because we've evaluated the square root of 16. 14 plus 4 means 18, and 14 minus 4 means 10. Both things are over 30. So plus or minus, both add the numbers and subtract the numbers, get two separate answers. And then reduce to lowest terms. Both of these divide by 6. So I'm going to get 3/5. And both of these divide by 10, so I get 1/3. So those are the answers to the problem. For me, if I've got a number in front of x squared, I always go with the quadratic formula. It's much easier than factoring, and it tends to get you the answer the most efficient way possible. Number 8, I think I'm going to go with factoring on this one. I'm going to throw the x squared over to the left, the 88 over to the left. So I like x squared positive. So I've got x squared minus 3x minus 88 equals 0. Okay. I'm going on the assumption that we're going to have nice friendly answers on the test, so expect that factoring can happen. If I got 1x squared, factoring is usually pretty easy. I'm looking for two numbers to multiply to make negative 88, that also subtract to make 3. Negative 11 and 8 do the trick. Negative 11 times 8 makes negative 88. Negative 11 plus 8 makes negative 3. So x minus 11 times x plus 8 is equal to 0. And once you get factored form equal to 0, then either factor 1 equals 0 or factor 2 equals 0. And those allow us to get the two answers we're looking for. So this answer, I move the 11 over and change the sign. Move the 8 over and change the sign. 0 plus 11 equals 11. 0 minus 8 is equal to negative 8. And those are my two solutions. So factoring works well on that one. Number 9, I'm going to go ahead and do the completing the square on this one, just to show you all three techniques. Again, I'd probably do factoring, to be honest, if this were the test, but just to show you all three techniques. Once again, x squared being negative, I like it positive, so x squared moves to the left, becomes positive x squared. 2x to the left becomes positive 2x. Minus 63 is equal to 0. If we're completing the square, first thing I want to do is I'm going to move the 63 over there, leaving a gap. So x squared plus 2x gap equals 63. 63 moves over, becomes positive. Completing the square, we're going to add half of 2, which is 1 squared. So half of 2 is 1, 1 squared is still 1. If this was an 8, half of 8 is 4, 4 squared is 16. So whatever you, half of it, square it. Plus 1, plus 1. You add it to one side, you add it to both sides. The left-hand side is now a perfect square trinomial. The square root of this, the square root of this, and this sign go in the parentheses. So x squared is x, 1 is 1, plus, and if this was 16, that would be a 4. If this was 9, that would be a 3. 63 plus 1 is 64. Once you get squared object equals number, then take the square root of both sides. X plus 1 equals plus or minus 8. Make sure the plus or minus shows up. Square root of 64 happens to equal 8. Then you move the 1 to the other side, you get negative 1 plus or minus 8, which just means negative 1 plus 8, which is positive 7. Negative 1 minus 8 is negative 9. So again, three quadratic equations. They're going to come out to either pretty friendly fractions or nice integer values. Again, for 7, I would do the quadratic formula. If there's a number in front of x squared, always use quadratic formula. These other two, factoring is fine, or the complete the square technique. I don't care what technique you use on the test, but 8 and 9 both can be done with factoring. If I was doing factoring here, x plus 9 times x minus 7 equals 0. X plus 9 equals 0. X minus 7 equals 0. X plus 9 equals 0 gets me there. X minus 7 gets me there. So factoring works on that also. Number 10, find the equation following line. I've gone to the trouble of putting these dots here to represent the actual points we're looking at, so there's no doubt. You know, sometimes people see something kind of close, maybe that's the point, but these are the actual points I want you to believe are on this line. So all I got to do is find the slope and the y-intercept. So starting with the y-intercept, crosses at -2. So that's one of the points, and again, it is a y-intercept, so we're good to go there. The other thing I need is the slope. I got to go from point A to point B. Let's just call this point A, call this point B. It doesn't matter which one's which. To get from point A to point B, I got to go down 3 spaces. That's negative. Go right 2 spaces. That's positive. Slope is rise over run. And again, the y-intercept is -2. Y equals mx plus b is the structure of a linear equation. Put the slope and the y-intercept in to write the answer. So y equals -3 halves x minus 2. Most common mistake when people know how to find those things, a lot of people forget to put the x, so don't be that person. I do count it wrong and I feel bad, but it is the correct answer with the x. Without it's wrong. Number 11, find the equation line that passes through these points. Now, you'll notice that this is a pretty big point to graph, -8 and 29 up. So if I was to do this on graph paper, it would be kind of painstakingly long to graph it and to count it and everything like that. But if you just imagine, I'm not going to use graph paper here, but if I was just graphing it. So let's say 4 here is and 5 is here, and -8's over here, and 29's up here somewhere. So if I graph 4, 5, it's right here, and I graph -8, 29, it's right there, and I got to go, the line goes like that. If I'm considering rise and run, okay, I got to go down to here, and I got to go over to here. This is going down, so it's a negative movement. This is going right, so it's a positive movement. All I got to determine to find out how far down I go is I'm going vertically from 29 to 5. How far is it from 29 to 5? It's 24 spaces. So I don't have to have actual graph paper to do this. I can kind of just figure it out from this. If I'm going horizontally from -8 up to 4, -8 to 0 is 8 spaces, plus 4 is 12 spaces. And again, going down negative, going right positive. So I can see very clearly that my slope, rise over run, is -24 over 12. And that just happens to divide evenly, so slope is -2. Once I know what the slope is, I go to find the y-intercept. I got to use a point. I'm going to use this point. And again, y equals mx plus b is my structure. Y is 5. M is -2. And x is 4. Those 3 values are right there for me. So if I substitute those 3 numbers in, y equals m times x plus b. That means 5 is equal to -8 plus b, which means b is equal to 13. Got to move the 8 over, change the sign. So slope is -2, y-intercept is 13. Again, y equals mx plus b. Don't leave the x off. If you want to verify it's correct, it's real simple. Put this x right here and make sure you get that y out. -2 times -8 is 16, plus 13 is 29. If I put this x in, -2 times 4 is -8, plus 13 is +5. So it's very easy to check those answers. Number 12, simplify. The problem with this, of course, is that we have a square root in the denominator. We don't like that. So I'm going to multiply both the top and the bottom by the square root of 7. On the top is the distributive property situation. Square root of 7 times the square root of 7 makes 7. Square root of 7 times 5 makes 5 times the square root of 7. On the bottom, the square root of 7 times the square root of 7 makes 7. The end. So it'll be pretty much like that. Multiplication by that fixes it. Just make sure you multiply everything properly. Number 13, this is just multiplication of radicals. Got this product and I got this product. When you're multiplying radicals, the outside numbers multiply like normal. So when I do the blue multiplication, -3 times +2 outside is -6. When I multiply the radical pieces, instead of doing 5 times 10 is 50, just break it down the rest of the way. This is 5, this is 10, and 5 times 5 times 2, pair of 5s, I get to pull 1 5 out, multiplied by the -6 that's already out there. Then I've got -3 times -3 makes +9. I'm leaving myself some space for this type of thing. And then I got the square root of, I've got again 5 times a number, 5 times 40 in this case. 5 is 5, 40 is 2 times 2 times 2 times 5. Got a pair of 2s, I can pull a 2 out. I got a pair of 5s, I can pull a 5 out. I've got a 2 left over I can't pull out, so it's going to be like that. So now if I simplify these down as far as I can, 5 and negative 6 makes negative 30 times the square root of 2. 5 and 2 is 10 times 9 is 90 times the square root of 2. Both of these have a 2 left over. Since they're both square roots of 2, addition and subtraction is legal. 90 minus 30 is equal to positive 60 times the square root of 2. 14, factor probably by grouping. I think that's a bad problem because it's not going to factor properly. Let's pretend this says minus 5j. So now actually we'll factor. Okay, so what I notice is the third position term is negative. So what I need to do is when I group them, I got rw squared plus 5r, no problems there. I got minus. Now I need this to be negative and this to be negative, so jw squared and positive 5j in the parentheses, minus this makes negative, minus this makes negative. So just be careful with the third position term negative, there's a minus in the middle, and that minus in the middle does distribute through to get back to our original expression. Again, we don't want to change any expressions when we do this. Now if I take a look at a common factor, in the first group there's an r common, so I take an r out, w squared plus 5 is left over. In the second group there's a j that's common and it's negative because again this minus sign is just being brought down. The j is the common factor and w squared plus 5 is left over. Factor by grouping works when these groups are the same, so w squared plus 5 is one factor, and whatever got taken out, in this case r minus j, is the other factor. The two factors do get multiplied together, and I'll make sure on the test that the problem is actually written properly so it does factor. And finally, number 15, a base of the right solid 17 inches high is shown. Find the surface area and the volume of the right solid. Dimensions are in inches. So they want surface area and volume. Surface area requires us to find the area of the base, the perimeter of the base, and the height of the solid. The volume only needs to be in h, but they're the same values. So I'm just going to start off by finding these three things. First off, 17 inches high, 17 inches high. Height's done. All right. So the challenge of this problem specifically is finding the area and perimeter of this base. So let's focus first of all on area. We have half a circle of radius 10, half a circle of radius 3. So the area of the 10 radius circle is just going to be 1/2 pi times the radius squared. The area of the 3 radius circle is going to be 1/2 pi times the radius squared. That's simply going to be 100 times 3.14. 314 divided by 2 is 157. And 9 times 3.14 is 28.26 divided by 2 is 14.13. 157 plus 14.13 makes 171.13. As far as perimeter is concerned, in past years people messed up on the perimeter here because they don't consider this little piece and that little piece. So be careful that you do consider that. We're looking for perimeter, this and this, along with the 2 red pieces. So let's start with the red pieces. That radius is 3, the big radius is 10, what's left over is 7. Same deal here, radius of 10 minus radius 3 makes 7. The circumference of half a circle is just pi times the radius, so 3 pi here and 10 pi here. So altogether, the perimeter of this thing is just going to be 14 plus 3 pi plus 10 pi, which is 13 pi. Be careful, this has a pi on it, this doesn't. I've seen people put 27 pi on this before. 13 times 3.14 is 39. Got to do it with a calculator. 13.14 times, no, sorry, 3.14 times 13. It's 40.82. So 14 plus 40.82. So if you add 14 to that, you're going to get 54.82. Just like that, I found the area and perimeter of this base. I know the height's 17 because I read it right there in the thing. So the volume is simply going to be BH, so that's going to be 171.13 times 17. The surface area is going to be 2 times B, which is 171.13, plus pH, which is 54.82 times 17. I I'm going to calculate with a calculator because it's easier. 171.13 times 17 comes out to 2,909.21. That's going to be cubic inches. In the surface area, 2 times 171.13 plus 54.82 times 17 comes out to 1,274.2 inches squared. And do make sure that you identify volume and surface area. Don't just write those two numbers and expect me to think you know what you're talking about. So make sure that volume's identified with a cubic and surface area with a square, and V equals SA equals. Make sure that's all written there when you do it.